Let's look at one of the main tests that can assess your pH management. When you go to get blood drawn, that's a venipuncture, where we're taking blood from a vein. We expect that blood to be carbon dioxide rich and oxygen poor. But if I want to know what's in the arterial side of your systemic circuit, I have to take an arterial blood gas. An arterial blood gas measures pH, carbon dioxide, oxygen, and bicarbonate anions. We can use these measurements to determine if our patient is in one of these four conditions, which are named for the system that is causing the condition. Respiratory acidosis is low pH caused by the respiratory system, and respiratory alkalosis is high pH caused by the respiratory system. The same goes with renal, or what is sometimes called metabolic acidosis and alkalosis. And arterial blood gas can help us determine if the lungs or the kidney are the culprit. And the added benefit of a blood gas is that it can also tell us if the acidosis or alkalosis is being compensated, or if the body is at least trying to counteract the condition. For example, in our case study, our patient is in renal acidosis, but his body is employing his lungs to try to compensate this. So this can get confusing because these four conditions are obviously diagnoses of problems, but the way that these four conditions work, your body can employ one of them to try to fix a problem. So it's not like respiratory acidosis only happens when you accumulate too many hydrogen cations from a respiratory issue. Respiratory acidosis can also result from trying to compensate for a kidney issue. Personally, I don't like blood gases because I can never remember the steps. And different resources have different steps, but what you have to do is stick to one, which is probably my problem because I've looked at many different ways and now I've gotten myself confused. Okay, so my only suggestion is to find a reference and stick with it. I can always identify an arterial blood gas that indicates either renal acidosis or alkalosis. And this is why. In renal acidosis, all of the items on an arterial blood gas are decreased. And in renal alkalosis, they are all increased. With respiratory acidosis and alkalosis, the pH changes in the opposite directions as the bicarb and carbon dioxide. So now the tricky part is determining that if the condition is compensated and if the compensation is partial or complete. That can actually be a matter of opinion, especially when it comes to determining partial or complete compensation. But no matter what, the key is to remember that once you get to the pH range, whatever organ system is compensating, it will immediately stop compensating. The compensating organ doesn't bring you back into the middle of a pH range. It brings you just inside the upper or lower limit, and then it's like, hey, you're in the right pH range. My job is done here.